Hi, James.
Hey, morning, Vikas.
Good morning. How are you?
I'm doing fine. How about yourself?
Very good.
By the way, happy Halloween.
Yeah, you too. Hey,
Any
one question. Oh, yeah, go ahead.
any plan for today or
So, taking my son for trick and treat, like everybody else, I guess. If you have still kids in that age.
yes, I guess yeah. I think yeah, that is for both. I mean kids coming, so maybe going with the
Oh
kids
yeah.
the trips and things like that.
Yep, absolutely. The table has to be out. Candies need to be out. Absolutely. It's fun.
Yeah, it's just one of those events in a year.
Yeah. Where actually you see people outside.
Yes, that's right. I mean, that's true. I think I like, and then you see all those kind of decoration things like that.
Yeah, exactly. There is another meeting tomorrow. Are you aware of it?
Yes, there's a demo meeting tomorrow. Yes, if you refer to the demo meeting, um,
Mhm. Okay, so that's a demo meeting. See, I was not aware of like the agenda of that.
oh, uh, I see. Is that David told you about that? Oh,
No, actually, I got it from Roy at Thai.
from
This
who?
message from Roy
All
at
right.
Thai. Yeah.
Oh, okay. That's supposed to be on the OCP calendar. If you are you familiar with the OCP calendar?
No, no, I'm not.
Yeah, if you go to OCP website, so we find that, but I can also quickly share you with the information here. Are
Mhm.
you referring to the related to this one, right? Or is a different one? Or is that like the CDS, the related to this the CDX, right?
Yes.
Um, yeah. Let me see how the best way I can.
Yeah, or who is the organization? I can directly contact, like to add me.
It's not add yet to sign up yourself.
Oh, okay. I didn't even know that. Okay, okay, okay.
Yeah. Who add you to this meeting though? Like, did somebody add you this meeting or?
Yeah, actually, Tim added me. Tim and Roy, like from Thai.
Oh, okay. Interesting.
Yeah, so
Hey
they added
Vikas,
me.
You know David. David is the one that you can reach out to. I think I can give
Okay.
contacts. Yeah. You know David?
Yes, yeah, I've seen. So I can actually reach out. Okay. Thank you.
No worries. Yeah, see other people joining. Let me quickly share my screen here. Hi Andrew. Hi Prayus.
hey James. Hey all. I see Vikas. Vikas,
Hello.
are you from Texas Institute of for Electronics, TI?
Yes, I am prepared.
And you work for Tim?
Yes.
I see. Nice to meet you. I'm from Siemens, and I'll be collaborating with you on the TI project, the
Oh,
engineering
really?
project. Yeah,
Okay. Good to meet you.
as with other people here, in some ways.
Yes. Uh, yeah, nice to meet you.
Nice to meet you too.
Um. Hey Rudy. Um. Yeah, probably going to quickly start. I think for today, I'm just going to go into the checklist here. So from this document, again, let me share the links for some new folks here. So you have the links. Hold on. By the way, I think for the Vikas and somebody new here, I think I'm just going to just do quickly about this information that you can subscribe, and I'm subscribed to this groups IO. So you send your email here to that subscribe, if you're able to subscribe to a mailing list. Then that's the mailing list that we're going to share all this information. We're going to send the updates on this link as well. So and that link will include this document as well. This, by the way, this document is like the specification that we're working on for the material design kits, which is part of the 3DK. So we are kind of like have a lot of coverage. I think especially I think with a lot of these schema kind of like actually it's an borrowing from the like ML, which is I think one of the I think open library I think that like other company like and NSYS has been using, like Andrew has recommended this one, that's why adopting this and expanding this focusing on semiconductors. So yeah, coming back to this the checklist here, I think we talk about we're trying to review the schema content. Okay. Schema content, I think all should be in November now. I think like since we end of October, but we still trying to target by November. So I think we also have that demo example that we pending on. And into pause. Okay, this is the sorry. Yeah, this demo, I think they have a new example that they're working on more information on the materials. I last time I talked to David, I think like this should be available. I think like in soon. I think David is tied up with some help out on his end. So I think but he will have bandwidth in November. I think it's just something I think we will work with him. I think like getting like a demo example, I think, and trying to fit into the schema that we have. Yeah, this one I think we need to hear feedback from Michael. I think he has a separate conversation, I think, with Andrew and others. We need to see. I think he presented that once, but I think there's some follow-up on the TG.
So
right?
I have been working on the material design kits, and I've merged the CTE and the Young's modulus from the package that we released in an earlier version. I've moved that to the dictionary, and so that I can share it with the design rule kit. But what I've discovered was that the CTE that we had in the package is slightly different to the CTE that we had in the design rule kit. So I've got some questions for you there. I've made a new structure for it, and I think we need to just clarify a few points. I'm what I was doing, but I didn't get finished with it, was as I was going down through all the parameters in the material design kit, I was making up an email with a list of all the questions, and I'm not sure where I have it now, so I have to go and try and find it here. But let's continue, James, and what I'll do is I'll come back to you with the questions once I find them here.
Okay.
Can you remind me what is CTE?
A coefficient of temperature expansion.
Oh, okay. All right. Thank you.
Okay. All right. So I think we're pending on this information, and then the next one, I think I follow up on the material sample information for silicon chiplet from demo design. I think, yeah, this kind of like related to this one. I think it has been redundant. So I'm probably going to just merge the two. So it's all from the demo information. Okay, that's also November. I think I have David here as well. So I'm going to probably just delete this one, not confusing. yeah, since we brought up separately again, at another meeting we just added it, but without realize they already have one action item added to that. And review initial draft by, okay, I think this is semi the schema, and also like the content. I think, let me just, this one actually, yeah, let me consolidate all this thing there, the schema content. So easier tracking. All right, and then there's like the review content, like the TG. Yes, I think this working group has been, I assume has been working on, I think like, how we're going to.
I didn't have another meeting because I hadn't made out my list of all the questions.
Okay.
So I want to finish. If I go and pull the meeting a little too early before I have completely reviewed all of the properties, then I will have. I think it won't be very productive. So that's the reason. You know, Bill has asked me the question, when can I get started on this again? But it's just too many priorities and trying to get through it. So I've made a good bit of progress on some of them, but I still have a few more to do.
Okay, so this is pending on the other one, in CT and other question. Once that clear, we're going to move on to this TG then, is that correct? If
we have time at today's meeting, let me at least close out some of those questions with you.
Okay, yeah, I mean, I'm not trying to mean to push on that. I know there's a lot of things going on, but I just trying to get the time right. Okay. Yeah, I think that's mainly it. I think like pending. I think this is kind of like mainly pending on the compatibility, and then just kind of summarize high level. I think, and then the demo informations, and then after there's some TG. I think information we want to follow up. And then I think just kind of overall review the entire document content. So I think that would be the 4 remaining items that I think I see we can still targeting for the November.
Yeah, I want to get it finished by no later than November 15th. By November the 8th, I would like to be presenting this to the JEDIC committee. So I will probably on November the 8th, I will probably be sending out an email to invite some of you guys here to the JEDIC meeting as guests, so that you are there to support me when I present it to the JEDIC guys.
I see. Okay.
What's the date of that JEDIC meeting, Michael?
Well, right now I have one targeted for the 8th. I don't think I will get everything done by the 8th. The second one, then I'll have to target for the 15th. And that leaves me then 1 week beforehand to get everything 15th to 22nd. So I would need to be submitting all the documents to the JEDIC for the ballot process on the for the opportunity to tell the committee on December 4th and 5th that we have a document that we would like to add to the JEP 30. So my timeline is getting pretty tight. So I'm going to aim for the 8th. If I cannot squeeze it in on the 8th, I will squeeze it in for the 15th. And then I have 1 week then left to finalize the dressing of the document and get it onto the JEDIC website. And then on the 4th of December, that will be a JEDIC only meeting. I'll be presenting it to the bigger committee. And on the 5th, we will make, hopefully, if I'm everything ready, I'll make a motion to formally include it into the JEP 30 standards. So we will come to a lot of conclusions.
December 6th?
December 5.
5. Thank you.
but only members from JEDIC can attend that meeting.
Yep.
Okay, so all right, that's kind of timeline. Yeah, I think that's probably many. I think updates from the meeting here. I think I pending for this item. So, anyone has any other agenda?
Well, I just have a question for you, if you have a moment.
Sure.
Okay, so I was not able to attend the OCP summit, and I'm just wondering whether at the OCP summit there was any presentation or demonstration about MDK or ADK.
Yes, good question. Thanks for asking that. Yeah, we did have a presentation, I think with David, on the MDK and ADK. Yeah, that would be a whole session is all about the projects that has been working on under OCP. I think that was on the Thursday. So together with all other power and performance metrics and things like that. So we did present that, I think both in the one session, I think ADK and MDK. So just kind of give an update where we are. So pretty much a lot of information from these documents and also the other ADK documents there.
I see. So was there good feedback from that?
Yeah, I think people starting to realize, I think especially I think the 3DK overall people to see that I think become very I think important that what we're trying to adjust here, I think having a standard and also a standard format and structure so that we can exchange information very easily. I think it's not just kind of individually, but then we can able to kind of connecting all this together. I think not only the parts, but also the assembly rules and then the material rules, and all together with others. We also touch points on the other testings and also electrical also the power information. So I think people, yeah, I think the major feedback we got really I think people really seen, I think that is very useful. And they are really looking forward to that. And especially I think hearing we are also working with other bodies like JDEC on this. So I have cooperation, I think really and have all participants, I think from many industries, many different EDAs, and assembly manufacturer. I think those questions have come up. So I think who are in this meeting. So we point out any other I think one question also comes up about other kind of effort. I think kind of the standardized effort, the 3D blocks and things like that. We try to adjust on that. We're trying to be more inclusive. So we eventually want to be compatible with the 3D blocks from the SMC. And yeah, I think those kind of notes kind of I have from that meeting. Yes. And yeah, also definitely the timeline. So I think people are asking about anticipating when this is going to be ready. So we kind of giving I think a projection. I think where we going to get everything done in November. Other things just logistic going to OCP and then the JDEC have to go into the committee approval and things like that. So targeting maybe late this year, early next year, to be available to the public.
Oh, that sounds great. Yeah, thank you for that update. Was that session recorded? So like if I wanted to go back and look at it and actually watch a recording, is that available?
Yes, it should be on the OCP website. Let me find out that, and then we'll share into this group. Right, I will send that email, yeah, to the group IO.
Okay. Thank you.
Sure. Hey, David, I see you are here. Do you have anything else you want to add from that OCP Global Summit presentation?
Was
there as well?
No, not really. You covered it well. I think the videos are posted on YouTube in OCP's channel somewhere. If you go and search, you'll see all the presentations. I think all of them, yes.
Okay.
Yeah, if don't find it, yeah, I will try to, yeah, later today I will try to look for that and then share the link as well in the mail list as well there. Just for, yeah, for I think that's the material for everyone. While we're waiting for Michael to search through the mail list, like anyone else has any other I think the power here? David, Tony?
No, I don't have any updates.
Okay.
All right, I'll share my screen then.
Okay, all right. Let me stop sharing here.
All right, let me know if you can see my screen.
Yes.
All right,
Yep.
okay, so this is the updated version of the CTE array, and to give you for reference, this is the one for that was previously released under the package section. Now, we said we're going to put this on the materials design kit, and so the first step was to move this into the dictionary, which I've done via the JEP30-D here. Now that schema will be shared between the package section, which is here, which is and the design rule kits, which is under here. And here you have the design rule kits, and under the structural one, you have the JEP30-D CTE array there. Okay, so the next set of changes that we did was on this sector here, we had simply the CTE array with the name. But what we did actually was we brought forward out the name, symbol, what is the symbol of the CTE, what's the symbol description of it, what's the definition of the CTE as a meaning. This symbol description is just describing what the symbol is, and then putting in a footnote. A footnote connects to a footnote array down here. So from discussions with JEDIC and IEC and E-Class, both of which we have MOUs with, and IEC are in the process of reviewing the part model for the purpose of adopting the part model as a global standard. They have suggested that we add some of the structure in here. So JEDIC has a document to describe a whole series of symbols. Each of those symbols have a name, and then they have several terms and definition documents, some of which have footnotes in it. And so they want to have that capability to add that in there, right? So that's one change that's been made. Second change that's been made is when I expand out, let's move this aside for a minute, the CT here, right? So I'm going to collapse some of this stuff here for you, right? So we said that we were going to create, as in the previous structure, a means to define each parameter as a set of values, or we could define it under a graph. So what I discovered under this structure, by the way, I'll just digress for a minute. At the last meeting from OCP, one of the concerns you had was we used to only have negative, positive, and total here, and people were getting confused what was the meaning of the total. So we expanded that to make it negative tolerance, positive tolerance, total tolerance, and the tolerance unit of measure being is it a percentage or a value. So that concept has got agreed with the task group. My question here is on the temperature condition, right? And you can see that the temperature condition now, all of these structures will remain the same. This belongs to the property, this belongs to the test condition here. The value was changed from a single nominal value to a structure based on, I think that request came from yourselves as well, because you might have a range inside in the temperature. This is the place where I have an issue with. In the prior version of this, the temperature condition here had units. The temperature examples. Where am I content? Had this section, had this structure here, units, right? So under the graph, which I expected to be a pictorial representation of the structure on top here, I discovered that the unit of measure under this was a choice between the CTE unit of measure and the temperature unit of measure. It's temperature being defined as degree C, degree Kelvin, Fahrenheit, and Kelvin. So, first of all, I have two questions here. First of all, the conditions for CTE is not a CTE. The conditions for CTE is just temperature. Isn't that statement right? So this structure is not correct as a test condition for CTE. What is, it should be just pure temperature. Isn't that correct? That's the question to the team here.
Yes, it is, yes.
All right. Okay, second question I have is, didn't we agree that we would take out Kelvin and degree Fahrenheit? Although somebody else later on said in a subsequent meeting that they wanted to add in Kelvin. But if we have Kelvin as the and degree C here, then we have to be consistent throughout it in the graph as well. So one group says we should just have degree C, and another group says we should have degree C in Kelvin, but not degree Fahrenheit.
Right. Let me jump in on that if I could, Michael. I'm the one who said take out Kelvin. Let me give a little bit of context for CTE. And I'm not like coming down hard here. I'm just giving you guys info. CTE, which I deal with every day, is always with degrees C in the denominator. Okay, never Fahrenheit, never Kelvin, so far in my life, and I'm not young. So what Kelvin is used for as a unit is for other thermal properties like thermal conductivity of a material. It's, watts per degree Kelvin. So that's the normal convention. Now we all know that when you talk, well, I think people know that for each of these, for both of those parameters, thermal conductivity and thermal expansion, the denominator being degrees C or degrees Kelvin, it's going to be the same number, of course, because you're just talking in the denominator about a delta of 1 degree, right? 1 degree Celsius, 1 degree Kelvin, same thing. But writing a standard, if you're going to follow industry convention, CTE is always per degrees Celsius. In my experience, others can correct me if they know otherwise. And by industry convention, thermal conductivity is degrees Kelvin in the denominator.
Degrees Kelvin. Do you mean to say degrees Celsius?
For thermal conductivity, it's watts per degrees Kelvin. What it means is two totally different groups of people came up with these. I'm just saying, whenever I see thermal conductivity, I see per degrees Kelvin. Whenever I see coefficient of thermal expansion, I see per degrees C.
Right. So I checked with the JC 14, another committee inside JEDIC, about what they were using for profiles. And they have stripped out Kelvin and Celsius and Fahrenheit and relied only on degrees Celsius. So my recommendation is that under the CTE UOM, that we would only have ppm per degree C, take out the ppm per degree per Kelvin, and have in the temperature only degree C, and limit it to that. And that's my recommendation. Because I think if you have down here Kelvin and up here degree C, this becomes just messy. It's not.
It's messy
consistent.
and unnecessary. So your answer and what the other committee is doing aligns with convention.
Yeah.
Actually, I wanted to make a comment about that. Yeah, it looks messy. I agree. And watts per meter Kelvin and watts per meter Celsius is the same value. However, the SI unit for thermal conductivity is watts per meter Kelvin. It's not per degree C. That's what the SI system has. So
Right.
I understand that we want to make
But
it sensible.
This is expansion rather than conductivity. What you're
I'm talking about the conductivity. The
Right.
SI unit is watts per meter Kelvin.
So Andrew, any thoughts on this? I know you know, Bill, you're an expert in the packaging world and substrates and PCBs. I think Andrew comes from a broader experience of analysis.
Well, yeah, I mean, I was going to say that
that's fine. That's fine. But I want to say I agree with what David said.
Yeah.
So David, you and I aren't in disagreement at all. It's just two different phenomena that we're measuring, right? What you're saying is true.
Yeah, I mean, the only thing that I'd say is that, you know, that I've seen all these, but then we do it across a huge number of industries. So, you know, if this is particularly for your industry, you know, for like packaging and electronics, then it is a lot better to try to stick to what the industry norm is, because that just cuts down confusion and cuts down, you know, excess units which you'll never use. So I put those in, I think, originally because that's what I've seen across the board in all the industries that we work with. But if Bill or other people are saying, well, we need to narrow it down to just those that are used within industry, then that's fine by me. And I think you probably have a better feel of that than myself.
Well, yeah, and maybe there's other ways we can deal with it, because I don't know if we necessarily want to limit these material design properties to current state of the art, because cryogenic stuff is happening and optics, and there may be all sorts of new things. What if we, for the domains that we're supporting right now, have these defaults? So if you don't specify the units, there is a default, but those defaults can be overridden if somebody wants to express them in a different manner.
Right. But let me
like that.
Let me look at it in a different way, though. Michael, David, and I are in total agreement, complete agreement, and we're coming, like, David and I have never met. Michael checked with another committee. We're in complete agreement on this, and I deal with this stuff every day. I have looked at thousands of laminate, data sheets, substrate material data sheets, and I know of no exceptions to what we're agreeing on. Thermal conductivity uses Kelvin, always, and CTE uses Celsius, always. So, and the three of us are in agreement. So unless somebody else has different data, I think we should just go with those. That's my vote.
I'm not disagreeing. I'm just want to make sure we don't limit ourselves. So Michael, a question for you.
I'm actually I'm in Mark. I'm in slight disagreement with you, in the sense that there's the SI system of units, and when I need to default to something, I would default to the SI system of units. Right. I understand I understand that the derivations and conversions that makes our life easier, right? Because as humans, we deal with Celsius all the time, and we understand it. Kelvin, people get confused what it means, right? Do they have to do the conversion or not? But the SI system says it's Kelvin. I go with Kelvin.
Right. So there's one more thing to consider. So as we have discovered, there is a ton of properties and units in JEDIC that are not in the SI. And so as part of the adoption process of IEC of the part model, they have members on board who are able to work with the SI units team to have additional units added to the SI. And so if this is a recommendation from the committee here, I can take that back to that discussion with the IEC group and ask them to champion the update to the SI units for changing of CTE from ppm Kelvin per Kelvin to ppm per degree C.
Yeah, that's fine. Right. The other route is if SI has already a unit for this, right? I understand that some may not have it, but some units do not exist. These need to be added. The question is the ones that exist. We should just adopt whatever SI is doing, right? The whole world is going to be aligning to that anyway.
Right. So David, here's the concern that I have.
That's not a correct statement, by the way. The whole world is not aligning with SI units. So
that's true.
That's the challenge. To the point is that we have two different data sources. One is SI, and I can confirm that Kelvin rather than Celsius is the SI unit. No argument, no disagreement.
Yeah.
But the world has sort of voted, and it's per degree C for this particular parameter. I'm not going to lay down in the road, but I'm just representing a lot of data that I see.
All right. So David, think of this as another problem. I'm specifying the condition in degree C. I'm specifying the value of the parameter per Kelvin. That doesn't make sense. If I specify the temperature condition in degree C, the ppm should be in per degree C. If I specify the temperature condition as Kelvin, then the CTE response should be based on Kelvin. But you cannot have a condition in one unit of measure and the response in a different unit of measure. To me, that makes no sense.
Okay, I would disagree with you.
Yeah, you can.
That one, and that actually makes sense to me, right? You know, that's why we had the unit conversion. We know how to convert.
Yeah, but why? Why are we doing this to ourselves? Why are we making things more complicated?
Because the world is getting more complicated, and you know, are we?
But this is a complication that's not necessary.
So, question, Michael, for you, for JEDEC, what is the scope of JEDEC? Is it for electronic system, or is it broader in nature?
It's anything electronics.
So, by definition, then JEDEC is focusing on electronic systems. So maybe if we want to support non-electronic, you know, material properties, maybe we can have a different SI2 flavor that has this. But you know, is it worth having a discussion with JEDEC to see how they feel?
I mean, JEDEC will go whichever way you want in this. I mean, it's up to the committee here to make the recommendation. What is the recommendation that you want to do? The bigger problem will be IEC, because IEC are more rigid than JEDEC are in terms of units. But having said that, they've also said that they have a team that can work with the SI units team to address imbalances, because they realize that SI units are not complete enough for the microelectronics domain.
Let me ask you guys a question. What would you do in this situation if you looked at 200 material data sheets? This is about a material design kit. You looked at 200 material data sheets, and all of them reported CTE with degrees C in the denominator. What would you conclude?
That's follow up to that. Would there be a problem if somebody comes and says my value is per Kelvin?
So what I'm saying is the current status is, if you look at 200 data sheets, there's a very high likelihood, based on my experience, that they're all going to be per degrees C. And you're saying, hypothetically, what if one of them said per degrees Kelvin?
Yeah, right. Here's my high-level thinking. We are trying to optimize something that I don't think is necessary, right? If somebody wants to put a value and annotate it that it's per degrees something, and the software understands that it's per degree something, and the software or the user wants to do calculation, assuming condition.
You're breaking up, David.
I don't think the format needs to optimize.
But there's one thing you're missing out, David. every piece of software that picks up this information has to have a piece of code to deal with that translation. So the entirety of the part model could have introduced much, much more flexibility in terms of all the data that it's collecting. But the downside of that is the cost of implementing that structure in a software tool makes it much more expensive. Software tools that has to deal with so much variability becomes more expensive and more problematic because there's a greater chance of mistakes being made. And we experienced that yesterday through another discussion that we were having in another portion of the part model. So the purpose, part of the purpose of the part model is to drive the industry towards a best practice. It's not to maintain status quo. If the status quo is not optimized, then we're not here to promote an unoptimized process. We're here to promote something that is best practice. We want the industry to conform to this to make it easier for adoption, not more difficult. So I would still suggest, my preference is still to restrict this to degree C. And if there is a need in the future to support ppm per Kelvin because somebody is requesting that, then we expand at that point the schema to adopt that. But don't allow all that variability in the beginning. Try and narrow it down. That's what JC14 did, and they stripped out all of the Fahrenheit and Kelvin. That's what other standards have done. IPC has done, and JEDEC has done in stripping out all the imperial and just using with metric. Both units, imperial and metric, are sanctioned by SI units, but they're not best practice. The imperial is not best practice. So all the standards have been stripped out of that. We should follow the same.
I guess I'll jump in. Why do we care? It's only a slope. I don't care if it's in Kelvin or degree C. ppm, whatever. I don't care.
Yeah, I think the general it's one level higher than that. You're right. Specifically when it comes to per degree C and per Kelvin, it doesn't make any difference. The value is exactly the same. And it could be either way, right?
And
we
superconductors, we
have
definitely quote those material properties in per degree Kelvin, but again, I think that's such a small subset. That's a niche. I wouldn't try to address it here. If you guys think 99 or 90+% is degree C, we go with that. And done. Because it's just a slope. I don't care. Just give me the number. The temperature up there on the other one, that kind of matters for me a little bit. It's more,
this one. So Rudy, what is your choice preference here?
I'll go either way. I don't care.
Or all three?
Just in general, in the semiconductor industry, normally, your units are programmed. You always specify the units. It could be, we've consolidated on metric, but it could be microns, nanometers, angstroms. You need to specify it. I mean, you can have defaults, but the EDA tools in the semiconductor industry deal with those units on a regular basis.
All right. Okay. So we need to
restricting and enforcing a specific unit. I don't know what we're going to see down the road, and I suppose we could always change it, but why not have that flexibility? Again, if the norm is these defaults and you don't specify units, let's default and define what those defaults are. And if you want to override the defaults, you specify the units.
I just checked a manufacturing standard under IPC. Most of you probably know IPC, or hopefully maybe. I deal with a lot of IPC standards, and I searched this pretty lengthy manufacturing doc on Kelvin and Celsius. I got 10 hits for Celsius and 0 for Kelvin. So that's just an FYI that sometimes industry norms are what people align with, regardless of SI units. But I think we're all kind of agreeing in some ways, and it's just a matter of what gets implemented.
All right, so let's make
just FYI.
I think let's make a show of hands. So option 1 is only degree C. Option 2 is only degree C and Kelvin. Option 3 is all three options, is all three variations. Which for option 1, which is just only degree C, on both the temperature and the CTE is ppm per degree C. That's option 1. How many in favor of that option?
Aye. Bill
One.
Hargan. Ooh, I'm alone.
No, you're not. I'm 2, right? All right, option 2.
What was that option again?
Option 1 is just degrees Celsius. Degrees Celsius for temperature, degree and ppm per degree C. Right, so are you for or against that?
Yeah, I'll vote for that one. That's simple.
So Andrew, Bill, myself, Justin, what did you say?
Nay.
No, right. Okay, option 2 is CTE is ppm per degree C and ppm per Kelvin with a default set to ppm per degree C. And temperature is left at degree C, Kelvin, and do we leave out the degree Fahrenheit?
We can rule out Fahrenheit. Nobody cares.
Yeah.
Yeah, it's an SI unit though, so we're changing the rules. But
Fahrenheit, Fahrenheit is an SI unit.
Yeah.
Fahrenheit is an it's degree Fahrenheit is an SI unit.
So
I'm pretty sure.
you're saying we can have support, so we can specify either Kelvin or C for any of these.
Yeah, in electronics, nobody uses it. Thermostat in my house, yes.
Yeah, but in electronics, nobody uses it, right? So option 2 is you have the 3 units for the temperature, you have the 2 units for the CTE. All in favor of option 2?
I got confused. I'm in favor.
Yeah, I'm
of
confused too. What's option 3? What's the difference between option 2 and 3?
Yeah, I'm in favor of allowing a default to be either the Kelvin or the Celsius, but that for both of those quantities you're talking about, you allow either.
You allow either and set the default. You can only set the default to 1. So what do you want to set the default to?
Yeah, well, I think, I think we should have the defaults be the defaults, whatever the industry practice is, and it sounds like we're aligned there. But I think we need to support the ability to override those defaults if, for whatever reason, you want to specify it with different units.
Right. So we're going to do that. So the CTE default is what? Per degree C.
Yeah.
Sure.
They defer and abstain to the experts, which I think they agree.
Okay, and the
I
temperature one.
Fahrenheit we can rule out.
So I need to make a new temperature type with just degree Fahrenheit and Kelvin and default it to degree C.
Right.
All right. Okay, that topic is discussed. Right, I will fix that later. I'll fix that later, right? Because that'll impact something else. Okay, my next question. I don't know if we're going to have time to deal with it.
Yeah, we got 1 minute, but
1 minute. Okay, well, we definitely don't have time. But my the area what I wanted to address is where I have it here. I have added in glass temperature and melting temperature. And what I don't know is, am I supposed to create a structure similar to this under glass temperature and melting temperature? Or is glass temperature and melting temperature a test condition of one of these items? For example, here, right? I have a temperature as the temperature condition. Do I have a glass transition temperature as a condition, or is the glass transition an actual property that you need to measure? Same thing for melting temperature.
Both need to be measured.
But they don't need any conditions in terms of temperature. They're just a single, melting temperature doesn't change with temperature. It is a temperature. So you just need you don't need all that structure with the conditions.
All right. Okay. I don't need a structure with conditions for melting temperature, right? No. For glass transition temperature. So I'm actually capturing it as a property, not as a condition, right?
Yeah.
Okay.
Well, I mean, Bill, I mean, is there a range? Because sometimes they quote these as a
range.
A range, don't they? Like melting temperature for solders, they have a when it starts to melt and when it's fully solid. Did you? And for glass transition temperature, do they give a? Sometimes give a range?
I said it like this. Jep 30. All right. Go back up here a bit.
Can I ask something? Shouldn't it be the minimum, like the lowest temperature of all?
Well, you need to know what it is. You need to specify whether it's a minimum or the maximum or whatever. And both are valid to record.
So like that. So this is fine for melting temperature.
Yeah, I mean, usually for materials, melting temperature is a single value. Where you get into ranges is when there are mixtures of materials and you're moving an independent variable that changes the dependent variable, which is melting temperature.
That's why I was saying, like the minimum, like whatever is the minimum, we should put that temperature, like one number.
So, well, do you want it this way? The top structure, which is just nominal with a footnote, or do you want it just with the ability to put in nominal?
I think minimum is built into the definition of nominal.
No. Well, you have a structure here
is,
that defines minimum. Nominal is nominal, minimum is minimum.
Okay, well, maybe you guys know otherwise. When, up to this point in my life, I've only seen nominal values. This thing starts melting at 230 C, that kind of thing. If you know otherwise,
solders, they'll report both. They have a particular naming scheme for solidus and liquidus for solders, because they do have a range. And people need to know when it starts to melt and when it will be fully melted. And that can be, that can be quite that could be 10 degrees C difference.
Okay, so in that case, you want to have it's not even this structure, Andrew. You want to put in something that says beginning to melt, or whatever that terminology is, and fully melted.
Well, I think you can, you can create a specific structure, but they're for solders. But I would go for minimum and maximum. I think you have, I think that structure you have there would be fine because people can use, for solders, they can use minimum and maximum, where they're often quoted. For other materials where it's less precise, they can use the kind of nominal tag.
Let me
Yeah,
ask you this. I have no disagreement with what you said, Andrew, but let me ask you this. What do you think people are going to put in their like data sheets? Because this is going to become a library theoretically. And do you think that people will be putting into their data sheets and therefore a library min and max? Maybe yes. I don't know.
Yeah, I mean,
no,
it's
but
quoted.
it's
quoted a lot.
Yeah, I would suspect some are going to put nominal, some will put nominal min max, and others will put max, right. So
and then
I
if
think we
you
could
are
work.
doing a very precise simulation, because some people really get in solders really in a lot of detail, and they'll start to study the melting range, and because a lot of things happen when solders melts and when it solidifies, particularly when it solidifies, you get stresses, and people will be modeling that in quite a lot of detail. So they'll need to know both of those temperatures because it depends on whether you're heating it up or cooling it down, on what temperature is important.
Guys, we need to wrap up. We got our next meeting coming up.
Well, and unless some of the guys, Andrew, or if you could hang on and let's just finish this, it would make life a lot easier for me. So I know if somebody may need to drop off, but if others didn't, it would be great to finish this off.
Yeah, I can hang on for another 10 minutes.
Thank you.
Yeah. Andrew, can you please explain it one more time? I didn't follow the solder, your experience. Like,
so what I'm sharing here is what I think Andrew is getting to. So in the process of building up to a liquidus temperature, you don't just subject the part all in one go to the relevant temperature because you'll have a temperature shock. So you have things like temperature ramp rate, then you have a liquidus temperature, and you tend to have a limited number of seconds that the product can be subjected to a liquidus temperature before it goes into damage, right? And you have peak temperatures, you have time within 5 degrees Celsius of a classification temperature. So all of these things are things that the JC14 control on the part when it is being assembled to the product. I'm assuming that you're talking about pre-liquidus and liquidus values that and it's similar in concept to what JC14 has.
Yes, that's right. Yeah.
All right. So
I've just put in the chat. I just randomly searched on the web for solder melting point, and this is one of the first tables I came across where you'll see that some of those solders, they are quoting min and max values which are quite wide, and that's because those particular formulations.
You mean the third row, right? 301 to 314, and then fourth one 296 to 301 range.
Yeah, so that's when it was 301 when it starts to melt, and 3114 is when it will be completely melted.
Yeah. So it sounds like a min and max is needed, and it sounds like we're better off going with, in case that we get nominal stuff in, we're better off going with this type of structure as opposed to this type of structure.
Yeah, because that's particularly for solders. Then other things will just have, people will quote normally just one value, and there won't be a range. So you need to also have.
And here you have the ability to do that.
And you won't know whether that's a min or max. You'll just have a single value, and so you put that into the nominal section.
Okay, so I have that there, right? Okay.
Are we assuming just standard temperatures and pressures? I mean, for those melt. I mean, I bring it up, Andrew, again, back to the 90% rule. I'm fine with this. I'm just asking, are people quoting that often? Because like for our cryogenic systems and stuff, we're,
That's true. Pressure has an impact. I don't know.
Right. But I'm fine with this because our goal is 90%, right? At least the way I look at it. I think this covers 90%. I just didn't know how often you're taking into account the pressure when you do those.
This structure covers everything now, because if they give it to me as min-max, I can do that. Or if they give it to me as a single value, I can do that. Right? I have the option here. It's all optional, so I can pick any choice, any combination of these.
Yeah,
So,
but
one
if you are
question,
just
Andrew.
working off
Oh,
data sheets where most of this data is going to come from, they won't quote pressure, they'll assume atmospheric pressure. If you're working in research or like, very specialized areas like cryogenics, as has been mentioned, then yes, you might start to get properties versus pressure. But
right.
it's quite
So,
rare, I should imagine.
Andrew, one thing. So pressure, atmospheric pressure, all the temperature. How actually would you like min max? How do you calculate that part? Like are there specs? How is it done in soldering?
Yeah, I mean, there'll be, for all these things, there'll be test specifications where it'll tell you how to measure and what the definition of the liquidus and the solidus points are. I don't know off the top of my head what those specifications are, but there'll be, all of these will have specifications
I
on how to
think
test.
the right question is, how do you even define the set specifications? Like you said, cryogenic engine, that's one. But
Yeah,
for
we did
normal
include that, didn't
things,
we, Michael? We included
Say
test
again?
specifications somewhere. We did include test specifications somewhere.
Yeah. The test for you have to elaborate.
like
So for each of these properties, the actual value you record might vary depending on how you tested it. So somewhere in the structure.
on the conditions. Yeah, of course.
So the electrical, I think we have it covered, and that's the one I would definitely use. For
Well, no, it's not the conditions. It's the actual test method that you have used. And somewhere we recorded that. I remember going through this.
Temperature condition, right there.
No, it's not the temperature. It's actual the test specifications.
Test conditions.
The test.
Yeah.
I don't know where I put that now. You'll have to tell me what.
Oh,
there
you go.
No.
No. Is there another section that is a definition? One of these.
Conductivity.
Can you tell me what property it belonged to?
Well, every property should have somewhere that you can say this property, this value was measured according to this test specification. Okay, I don't think I have put that in there. I would probably need to have another session on that. I could have sworn, because that was one of the things that I'd sent through. Yeah, I'll have to go and dig out your emails again now. I don't remember. I remember talking about it, Andrew, and I don't remember actually.
I thought these had it right here, right? Like field strength, the conductivity, because they have a test condition right there. Yeah, no, I don't mean test condition. It's the specification. So there'll be different specifications, how you do the test, which equipment you use. And those will, you could be testing the same property, but if you use a different test method, you might get a different value. Understood. And for things like dielectric strength, they can vary quite a lot according to the different test specifications that you use. Dielectric constant, yeah. So I think what we needed to do was to build that into this structure, but I don't think I have that in there.
But wouldn't that be a really tough one with so many choices out there? But you are going to put some.
So the test conditions apply to the measurement methods. Do they apply to every property? I would assume that measurement
every
method,
property you should be able to say which test method you used.
All right, so isn't the test method for dielectric going to be different to the test method for field strength and different for the dissipation factor? The method by which you're under every one of these structures, I have to define. Yeah, it probably goes with the it goes at that same level as you've got description, footnote. Yeah, maybe we decided to put it into the description. I can't remember, but it might be worth pulling. So at that same level, yeah, you'd need a test method. Now, is this test method just going to be a string, or is it going to be a very specific choice of test method specific to a dielectric?
There are a discrete number, a limited number, but I wouldn't be in a position to say what they would be. So, putting in just a string. If somebody wants to do all that research and work out what all the test methods are available, but I think you're probably safer to put a string in. Otherwise, you have to maintain it. It will vary over time.
Right.
Test methods will come and go over a 5-10 year period. So.
All right. Okay.
Is there any example, Andrew, like that can be found somewhere for the test method?
Yeah, I'll just do. I don't.
Yeah, this is
solder melting temperature test method. I'll type that into Google and see what comes up.
Well, if we're talking about dielectric constant, that's stuff that I deal with every day.
Yeah.
So
are they IPC test methods? Are they?
Right. But there are also some ASTM ones. There are also occasionally bootleg ones that people figure out. But IPC has, let's say, well, I've counted them. I've got a slide that describes the evolution of IPC dielectric test methods. There's like a dozen of them. And everything you said is true, Andrew, that it is a discrete number. I know pretty much all of them, but at the same time, I'm not sure that we want to go get in the business of taxonomizing all of them rather than just letting people put in a string.
Yeah, I'd agree, because otherwise it'll be a constant maintenance burden on somebody.
All right. Okay. So what I'm going to do is put down a test method for how and make that part of this structure up here. Okay. All right. So I'll add that.
Let me ask you a question though, Michael. Are you separating DKZ from, like, let's say DKXY?
I don't know what DKG and DKSY is.
Well, the Z is the letter Z, like the Z.
Yeah. Sorry. Yes, I have that structure there. This is what you gave me the last time. You told me to make a choice here, right. An XY value or and a Z value. Okay. Or and I had here, if this is necessary, since the direction of the X and Y may not be known or may not matter, hence recommending using XY. So did you want to have this choice in here? Or did we, and I think we agreed on that we wanted to leave the choice in there just in case in the future it's going to be left.
Well, I wouldn't propose leaving that choice in there. Just because let me flesh this out and tell you why, or one of the reasons I thought of this. The measurement methods that I mentioned for IPC, there are 12 of them. And there are other ones that are outside of IPC. But the 12 that are within IPC, some of them are Z direction methods, and some of them are XY direction methods. Nobody is measuring DKX and saying it's different than DKY. It's just it's either in the XY plane parallel to the material, to the substrate, or it's essentially orthogonal outside that XY plane. Those are the two. And the measurement methods are one or the other.
Right. So your preference is to go like this, like that.
Mm-hmm. Right.
Okay.
And you might want to consider the fact that the measurement methods that we were describing correlate to these. Because you're not going to have a measurement method that measures X, Y, and Z. It's going to measure
all right.
Z,
Okay.
or
So
it's
that
going to
means
measure X, Y.
that means you're going to have like this. Like that.
Yeah.
All right, so I have to put that under a different structure because okay, I'll have to do it this way because XY.
This is good what you just did. This is appropriate.
The dash test method. Okay, and then I take this test method out here.
Yeah, I think if we're being granular, this is the right way to do it.
Okay, so this one breaks, right? So if I take this out and I have up here, I have a value of the singular value. In that case, do I have on the singular value, do I have a test method for that?
Well, I don't know. Let me just say it this way. There are some people that you would say DKZ versus DKXY to them, and they would just stare at you blankly. But in reality, you're either measuring DKZ or you're measuring DKXY. And they can be slightly different, and it depends on whether the material is anisotropic.
Yeah. Because if you just went to a polymer, say a polymer data sheet, it would just give you one value because it's completely isotropic.
Yes.
So in theory, you'd put in the same value for X, Y, and Z, but that's kind of adding a kind of, so the X, Y, and Z is really for laminates, isn't it? Where you see
glass reinforced stuff that's glass reinforced.
So that ignoring this last piece, this is about right here. Now, does that mean that this is? Let's go back to the top here.
Andrew said something very important right there that essentially corrects what I was saying.
All right, all right. I'm conscious of the times, guys, because I know some of you are going to just drop off quickly, and I want to be able to get through a bunch of points. So I'm taking, if I take this piece out here, right, and I'm now left with this structure. You're in agreement with this structure, and the test method is down here. Do I apply that structure to field strength, which is exactly the same structure?
Yeah, but let me, Andrew essentially corrected something I said, and that is that I was speaking to anisotropic materials, which have glass reinforcing some sort of resin system. Andrew is saying correctly that isotropic materials, one DK value is going to apply to the X, Y, and the Z direction.
Yeah, and that's that one here.
Okay.
So we have two choices. Yeah, we either put one value in or we specify X, Y, and Z, which I think is fine. That should cover the cases.
Okay. Fair enough.
All right, so we'll cover with that. Now, does this structure apply to field strength, dissipation factor, bulk conductivity, bulk resistivity, not melting temperature, I guess, right? Thermal expansion, thermal conductivity. Do I need to, for every one of these, do I need to strip
should we
this
just go
out
down them and we'll just agree, because we should be able to say yes or no to whether you need this kind of structure, or just if you just start from the top of those, and
so
we can quickly give you
bit. All right, so let's see if I can do it quickly, right? Copy this structure.
Well, Thermal
Okay, so
expansion for sure.
Yeah, let's just go down the list and then we won't get.
okay. So I'm just going down the list. So first one is this level here, right? Under field strength. Yes or no for field strength?
Yes.
Yes.
Okay, so take this
Field
guy
strength
out.
is proportional to the DK.
Okay. Let's not go into the description. It's got to be yes or no, although we'll be here for a long time. Dissipation factor.
Yes.
Okay.
Not as much as DK, but yes.
All right. Bulk conductivity.
No.
No. So what do I have for bulk conductivity?
You could just have a single value, I think, can't you? You don't. Bulk conductivity is just.
Do I have a test method?
Oh, hang on. Bulk conductivity. That can be directional, though, can't it? Yes, it does need this. Yeah, I think it needs the same structure with a single value or an X, Y, Z value.
I feel we should have more time for this, like next week.
Okay. So if it's on bulk, what did you say there?
Oh, I was saying like shouldn't we do it next week when we have more time? I can't even process the information right now.
We're trying to determine whether each of these properties is directional in an anisotropic material or it's not.
Yeah, go on.
Right. Next one, bulk resistivity. Well, if it's in for
It's the
bulk
inverse,
conductivity,
yeah,
it has
yeah.
to be here for this one.
Yeah.
Okay, next one down is we'll come back to that one. Melting point, melting
No.
temperature, not applicable for that, right?
No.
Okay, thermal expansion.
Yes.
Thermal conductivity.
Yes.
Okay. Next one I have is heat capacity. I have nothing under heat capacity. And I have
I think that should be, yeah. Specific heat capacity, no, it doesn't apply. That's definitely a bulk property. It doesn't matter what kind of structure it is. Heat capacity, I don't know why it's there. That can.
So what? Okay, I have to come back to that guy. So specific heat.
It just needs a single value. It doesn't need the X, Y, Z.
It's okay. Single value there.
Same for density. Doesn't need X, Y, Z.
Okay. I better check this. It doesn't have it there. Okay. Structural. Young's modulus.
Just. I think all of these will need. They'll all be directional.
Yeah, it is. Young's modulus, Poisson's, those are three-dimensional.
Okay.
So I do really need to go. Can we just kind of maybe just go through and just say yes, yay or nay, and then you can make the changes later.
As long as they're all, yeah. Okay. Yes or no?
They're all yes for this one. They all need, so all the mechanical structural ones need to be X, Y, Z,
right,
as well as a single value.
So the pieces I've left to try and resolve are the where's that one there? Specific heat capacity and the glass transition temperature. I don't know what goes in under this.
That the glass transition needs to be its own meeting, or its own meeting topic. We're not gonna with people dropping off, we are not going to be able to land the plane on this one.
All right. So can I do my calendar is pretty tight now. Calendar. Could I do tomorrow maybe? Could I do tomorrow 8 o'clock in the morning? Where are you, Bill? You're in California.
I'm sorry,
I'm in the west.
sorry, I can't
west
do
coast.
tomorrow.
You can't do tomorrow. So Wednesday, 4th to the 8th. What slots do you have, Andrew? You're in the UK, Andrew, right?
Yeah. So in the morning on the Monday, I could morning your time, Monday the 4th.
I can do 9 o'clock in the morning my time, which is 7 o'clock in the morning California time.
Could we do that at 8 Pacific time?
That's 10 o'clock my time, which is 4 o'clock in the evening your time, Andrew. But there's an hour change, so I'm not sure how that's going to work out. So
I think that's fine.
All right, I'll set it up for.
Yeah.
I give ourselves a 90-minute or 2 hours discussion. By then, I'll try and have all this wrapped up for you and finalized, and I'll try and put it into a document, a Word document that you'll be just saying, right, this is good to go.
Yeah, I don't want to have a 2-hour discussion though, but
I don't think we need 2 hours. We just need to don't get sidetracked by temperature units.
All right, I'll set for 90 minutes. Hopefully we finish in an hour.
Okay, sounds good.
All right.
Yeah.
Right, thank you guys.
Okay, thanks already. Cheers, bye.
Alrighty. Okay.
Bye.
Awesome, thanks.
James, you still there?